Find the derivative of y equals sine of t plus 2 all over cosine of t, A, by using the quotient rule, B, by taking the quotient first and differentiating the result. For part A, y is made up of the quotient or division of two expressions, sine of t plus 2 divided by or over the cosine of t. We can therefore make use of the quotient rule for the derivative. Y prime, which can also be called dy dt, will be the quotient rule, derivative of the numerator. Derivative of sine of t is cosine of t. Derivative of the 2, a constant without a t, is a 0, so just cosine of t, times the denominator left alone, so times cosine of t, minus the numerator left alone, sine of t plus 2, times the derivative of the denominator. The derivative of cosine of t is a negative sine of t. All this over the denominator squared, cosine of t squared. We can multiply the first expressions. Cosine of t times cosine of t will be cosine squared of t. For this next set of expressions, we have a double negative, so it's going to be a positive, and we're going to distribute that sine of t into the sine of t plus 2. Sine of t times sine of t will be sine squared of t, and sine of t times a 2 will be a plus 2 sine of t. Remember that they'll both be positive here because we have a double negative, and the negatives will multiply to become a positive. All of this is divided by cosine of t squared, which can also be written as cosine squared of t. So y prime, or dy dt, equals to, I see cosine squared plus sine squared. That's a Pythagorean trig identity. Cosine squared of t plus sine squared of t equals to 1, and we can replace that entire portion of it that we see right here with a 1. Let's do that. That will certainly simplify this. 1 plus 2 sine of t, all divided by cosine squared of t. Now another option we have here is to separate each of these over the common denominator. The reason that we would do this is it would allow us to write a different trig function to indicate the division. We have, for example, 1 over cosine squared of t, and 1 over cosine can be called secant. And then we also have a sine over a cosine, but we need to separate because we have cosine squared in the denominator there. So what I'm going to do is take this second expression and separate it into a sine over a cosine and a 1 over a cosine, because the sine is not squared and the cosine is. So we'll need to move one off to the side. But this is how we can rewrite each of these into a separate, different trig function that implies the division happening. 1 over cosine is secant. 1 over cosine squared is secant squared. So that first term is just a secant squared of t. That second term is a 2 times sine over cosine, which is a tangent of t, and then 1 over cosine, which is a secant of t. So instead of having a fraction, we can write a secant squared of t plus 2 tangent t secant t. So there's our derivative y prime, or dy dt. For part B, we're going to take the quotient first. So I'm going to rewrite the y exactly as given. Since we have a single term in the denominator, it's not added or subtracted together with anything, we have the option of taking the quotient first and directly by separating each of the terms in the numerator over that common denominator. So I can write this as sine of t over cosine of t plus 2 over cosine of t. Sine of t over the cosine of t is the tangent of t, and 2 over the cosine of t is 2 times 1 over cosine, which is 1 over cosine equals to secant of t. Tangent of t plus 2 secant of t. With this, we no longer have a quotient. What we have are two terms that are combined by addition, and we can therefore take the derivative of each term separately and add the results. And so now let's find the derivative from this. Y prime, or dy dt, will equal the derivative of tangent of t will be secant squared of t plus 2 times the derivative of secant of t will be secant of t tangent of t. And since the order of multiplication doesn't matter, 2 secant t times tangent t is the same as 2 tangent t times secant t. So the expression we ended up with for the derivative in A, secant squared t plus 2 tangent t secant t, matches what we ended up with in B, secant squared t plus 2 secant t tangent t. The order of multiplication doesn't matter. There's our derivative.